did you have to schedule your class this early?
Because I'm an early person.
All right.
And I don't care that you're not.
Because it's a required.
Yeah, for software engineering.
Yeah, because it's a required course.
Hey, look, if you want to teach your teacher the stuff that actually do the stuff, you're coming in at 8 in the morning. You don't want that.
But I am really glad that you did not schedule your class at 7:30 in the morning.
I tried. I tried to make this one earlier.
Really?
Yeah.
The senior project originally was scheduled at 7:30, but then we found out.
Yeah, but then they moved it to 8. They won't let, yeah, it has to fit one of the normal slots. So I asked them, how early can you go? I tried, I would have done it like at 6.
I'm just letting you know, most of us would not. Most of us would switch like to a different concentration.
I bet you wouldn't.
I 100%.
Really?
Yeah.
You would avoid me just because of a 6 a.m. class?
Yeah.
Really?
I would have gone for
What?
10 honestly.
I mean, like, the fact, like, in order for a 6 a.m. class, you have to wake up at
Yeah, see, he's up eating first breakfast at 6 a.m.
All right, guys.
Yeah, and then he hits third breakfast right after this class.
Uh-huh.
If I don't get up at 7, I'd be up at 6:30 in the morning every single Thursday. Without being able to have.
You gotta get up at 5 a.m. Get your 10-mile run in. Downhill both ways.
What's down?
I
Oh,
just get the momentum going.
okay.
All right, let's see. Do we have homework?
It was to understand what the code was.
Okay, did everybody understand what it did?
Somewhat.
So no, you didn't even try.
No, I did try. I did actually look at the code.
Don't you think it's a little early to be lying? Yeah, you might be right. Maybe I am ruthless.
Yeah, I think so.
Maybe that's just, like, one
'Cause I'm
cup
probably
coffee
the only
with
person in
a
this
cup.
class that actually read the code and everyone else did.
I made a lady quit this game. I've been playing this new, if you're into tabletop Dungeons and Dragons, this game, Demio. It's ridiculous.
Yeah, we talked about
It's so good. So I was playing a game 2 nights ago, and I made her quit. She was playing an archer. She was doing like 3 damage, and she was taking all these risks. And I look, I don't even remember what I said anymore. It was like my normal shtick. It wasn't like me going like off doing something ridiculous, but she didn't like it. She quit. We were better off without her.
Was it just this random person or did you go?
Yeah, random person.
Oh, gotcha. That's fun.
Well, she was like jumping right into the middle of the crowd, and she's an archer who's supposed to be shooting from afar.
Yeah, that.
She's doing 3 damage.
Okay, I'm sorry. That is just kind of. I mean, I even played.
Yeah.
It's just
Where I went pro mode, I had this legendary card. So I jumped, I was an assassin. I jumped into the middle, did all this damage, and then immediately cast this immune for 3 turns. So I'm standing right there and they're just beating, I'm doing no damage. Pretty legit. Then she dies next turn. She's standing there with the bow at range 0. No, you can't kick people. So you just have to shame them into quitting. All right. So our language right now does something, right? But very little something. Right now we've written some code like this dude, call some function on an input. Right now our functions are very limited to the inputs that, well, are very limited because we only allow a single input, right? One single input, no more, no less. And we can imagine that if we're writing functions in a real language, we expect to be able to pass 0 or more functions. Now, our 0 more parameters. In our current language, passing 0 parameters, though, doesn't even make any sense, right? Because we can do very little. All we can do right now in our language really is resolve a variable. That's it. All right, so from your perspective, what's what's the next simplest thing you think we're missing in our language? Go ahead. Okay, yeah, but do we even have a way of using that right now? I suppose we could change some function calls, right? But then we'd have to, one of our parameters would have to be a function. Yeah, we don't have that ability in our variable environment yet. Go ahead.
I was gonna say like maybe built-in functions.
Yeah, let's go simpler. What are we missing in our language that's in every other programming language?
Strings and ints.
Strings and ints. Okay, tell me about the int part.
The ability to add, declare an int and to add it to another int.
Okay, well, I can already declare it in right here. Here's a = 7.
Well, what about adding?
I can't do math yet. You said ints, not math. You described math.
Find ints with math.
Do you really think you should be this close to the fray if you can only do 3 damage? Quote. All right. Shouldn't we be able to say something like that? Why do I have to pass a variable? Shouldn't I be able to represent literals? Just a number that says, hey, we don't have to resolve this dude. He's his value. He already started off as his value. All right. So we maybe want to expand our language to now support literals. Let's go back here, since this guy right now only exists in a picture. I'm going to go ahead and I'm going to create a language reference. No language ref. All right. So a no lang expression comes in 3 different formats, right? Right now, we have something that's just an identifier, something that's this lambda thingy, and then something that is this no expression thingy-majiggy. All right, so, huh? Right. Identifier, an open parenthesis, followed by, actually, do we call it a lambda?
Yeah.
No, that's the third one. Our third one's called func expression. So yeah, ours is the word func, right? Where's our code? Function. Function, the word function. It's func expression in our parsed version, but the actual language itself.
I don't know why, but whenever I think of func expression, I think of funky expression.
Like funky dance, or I do that during chapel sometimes when it's especially not sucky hymn. Is today Battens?
No, he's Friday.
Okay. What's today?
I don't know.
That was a good one.
It's the day before Friday.
I don't want matins, and I don't want the sing-songy where he asks all the quiz questions and then you just pick a random hymn.
Oh, that one, not
Oh,
the
today is Matins.
Oy,
Why don't you Matins?
I don't know what it is, brother.
matins feels insincere
Why does it feel this
because you're just reading.
a little bit, yeah.
Yeah. Matins is actually, quite it's words right out of the Bible. So I mean, there's nothing wrong with it philosophically. It's more of a personal. I like sermons a lot because I feel like I like listening and learning something and seeing how can I apply this to my life, and so I guess that's a selfish thing where it's like, what's in it for me, as opposed to going there to worship God. But so matins would probably be more of the worship God side of things, which I'm too selfish for that. I could be kicking ladies out for using, trying to do melee with a bow. You're absolutely right. So in this case, I am giving bad advice. but I'm a poor miserable sinner, and I'm not going for Madden's. This is what it ultimately comes down to.
At least you can.
All right, so we have a function followed by a single parameter, so open parenthesis. I'll put a symbol, I think is what our a formal blah, blah, blah thing is, and then a no-lang expression. And I know at this point I'm rewriting effectively using no-lang nomenclature, whatever, from this guy, but we're going to be adding to it. So we're almost creating a reference document for our language right now. Go ahead.
Why is it that when we originally wrote this, like, but when we were planning without writing no code, why did we use X for the symbol and the no?
X for the symbol and the no-lang expression. Oh, you mean when we actually wrote our code?
Yeah.
Oh, well, for the same reason that we would have done this in Java. If you wrote this in Java, you'd have a parameter. I mean, this can be whatever you want. You know, this could be LOL or something like that, whatever you name your parameter. And I'm passing in whatever this value is for that. So even though these both say X, they mean different things. This guy creates a variable binding to whatever was passed in. And the name of this variable right here is actually, hold on, I highlighted the wrong thing. I didn't mean this X, I meant this A. So this A gets bound to this X. So right here, this is the name of the parameter. This is me using that parameter. And nothing would actually say that I couldn't do this. In fact, we can write this. What will the output of that be? 5, right? I'm passing A in for X. A gets resolved to its value, which is 7. Then I'm choosing not to use that parameter inside the body of the function. Instead, I'm just saying, hey, here's another expression. This guy's a var expression that boils down to a 5. Let's assume it still works. There's our 5. Right? So all we changed is what does the body of our function do? And we've just chosen to make this a waste of time. This is our way of creating a no argument function right now that we don't intend to use the parameter. Go ahead. Well, no, because I mean, you still have a more global scope. I mean, you have, when a program starts, you have a global variable environment. Yeah, I mean, this is our overarching variable environment that we're just kind of randomly giving ourselves starter variables. So this would be like if you create a Java program at the very top, you said int age equals 21, int a equals 7, int b equals 5, int c equals 23, and then the whole rest of your program has access to those guys unless you create more local versions of one of those variables, because all variables resolve to the most local definition. Okay, back here. So that's our second production. Third production is call no-lang expression followed by a no-lang expression. That's the official syntax, with our expectation being that this first no-lang expression is this production. And our second no-lang expression is, as of right now, this production. But we're going to add another production to this. So this is the current state of our language, right? So now what we want to do is we want to add something that's just a number, in preparation for maybe doing some mathy stuff, right? That doesn't involve resolving a variable. I mean, we are roughly somewhat limitedly prepared for mathy stuff right now, but we have to hide all of our numbers inside of variables, so if we wanted to say something +1, assuming we do have mathy abilities, I would literally have to put the +1 inside of a variable in order to then resolve that variable to add 1 to something, instead of just saying whatever +1. All right, so we're going to give ourselves the ability to say, look, all I want here is a number. I don't want to store it anywhere. I just want it to be a number that I can use for something else potentially. Go ahead.
You're saying it with numbers, but we're using numerals, but this would be the ability to have just display like an A.
As we are writing it right now, we're going to do it as just a number. But you're absolutely right. Nothing would keep us from having another thing that said we were allowed to have symbols, or something like that. Yeah, I mean, I use the word literal generically, but we would have, this would be an int literal versus a char literal versus a string literal, those types of things. All right. So in order to add a new ability to our language, we need to add this to our parser, and we also need to add it to our interpreter, both sides, right? All right. Now, just so we don't get confused in our language, I'm going to go ahead and dump our unparser. That was an exercise to practice going back and forth between parsing, but that's not really something practical that we're going to be using. So I don't want to lull us into thinking we need to update that every single time we add a feature. So we need to make our parser parse the new feature correctly, and then we need to add the interpreter to make it so, make it work. All right, so in our parser, we can add a production in here. Number. So if no code was a number, I just put it before the symbol thing. Then what are we going to do? Maybe create a list, and maybe we call this guy a lit expression. Literal expression. We can. So we call this a num lit exp. See, as soon as I said lit, you thought about me, didn't you? You would show up to my 6 a.m. class. Yes, you would.
You think I would?
I do. I do.
Probably the majority, probably.
And deep down inside, I think you know you would.
Oh, I know I would.
You just want to act all tough, like that archer that gets right into the fray. Well, I understand you might not be in a good mood, but that would just make it more fun.
I can't believe I'm saying this, but I'm very glad the administration restricted the
I know, I tried. You get great parking at 6 a.m.
I got put down
I don't,
before
I was
the
about to
meeting.
say, I'm like, I got good parking at such very.
Oh, I bet you have like
No, but I tried to negotiate that.
It might benefit other people.
When I was giving money to the business building, I wanted my own spot.
And
No, they thought it would create too much controversy on campus. Like, why does he have a spot? Nobody else has a spot. Huh? Yeah. Because I gave you $5 million. That's why. Okay, a guy gets a spot.
it's like controversial without it.
and people are like, why you take the spot? You take the spot.
Would you have like your name on it? Jane?
No,
Like,
you would
or
have
would
this
you have-
awesome fact.
I have the logo,
That's smart.
and there would be lasers.
You could like cut it into the pavement.
No, you invest in a laser machine. and
They
then
stamp it in the pavement when they fill it in with gold.
Like you pay to fill them with gold. That would be one expensive way. And you almost need to fill it with something like that.
Nah, I'm not a gold. I don't even wear. I mean, this is a plastic, rubber wedding ring. My gold one's in my wife's jewelry box.
Would you have like,
Oh, I was
like the
considering-
dragon tag made of like tears?
Yeah, so good.
You ever use those or?
To be honest, I don't know where they are. And now I'm never going to play normal tabletop again because I can play it in VR.
I'm so upset.
I do have. I mean, they are somewhere.
They're
They're in the basement on one of these two walls in a box. So I know the rough location. I just haven't dug them out. What, dice made of a meteor?
Yeah.
That's so cool.
Well, it's cool to like a very small percentage of the population that is also excited about the tabletop VR game I've been describing. That's the same people there's a small category of people. You know, if you're like really into Grand Theft Auto, you are not going to be into the table.
There's a lot more of an overlap than you think.
Well, yeah, it probably is. Some of those tabletop people are pretty weird.
I also want to put out there that we're probably a population that would really enjoy it. You're probably like, you know, rather than music majors or something like that, you're speaking to like.
Not but I think you're right. There's a higher chance, but I think it's the because you've grown up with video games all along, you've lost that feeling for the need of the tabletop stuff. Like, you know, you don't have imagination anymore because it's all spit out for you on the screen. You don't have to imagine an explosion. You get the explosion. It's just there. Yeah. You call this 4K?
So if you imagine the explosion, it's at high quality.
I'm only getting 800 frames per second. It's not going to cut it. I almost think I maybe saw a flicker. That's not smooth graphics. Come on. I wouldn't want to make it better. Somebody else gets paid to do that. And I'm not artistic, so no. I think the flat answer to your question is no, I couldn't make it
Yeah, I
better.
was gonna say, someone make that.
No, I would just I'd pay the $50 for the game and let somebody else pay a bunch of money to make it better. All right, shut up. We're writing a language here, people. I said it in my 200 class. They look shocked. All right. So we're going to create a numlit expression here using whatever was passed in as our no code, right? So we've just added a new flag for a new type of value. And this guy is called a numlit expression. Yeah.
Will there ever be a situation where the order in which these are
It's sort of we already have that situation with well, because we've chosen to always label our stuff, I think the answer is maybe no, because we're being explicit in our syntax. But if we chose, for example, down here to leave the word call out and just have a list containing 2 elements, that would almost have to be inside the else. We've covered everything else explicit, and now what's left is this guy. But instead, we've chosen to always have a call to action, what we're going to be doing. And since we have that word, I think we can do it in any order. Yeah.
Is there a reason why we're not taking part of no code and just getting it code?
What are we talking about here?
For number? I'm guessing you explained it.
This guy here?
Yeah.
Well, because I mean, this is going to be, we're somewhere in here, there's going to be a recursive call. So one way or another, we got no code that is literally just a number. Yeah.
It's happened with our code so far every time, but the first time this goes through, will it, like, when the first time the no code goes through, will it always put the else? That's what I think is true, but
In our current language, yeah, because our current language really only supports, our only executable line of code right now is a call function. This guy can't do its thing on its own. This guy can't do its thing on its own. This guy can't do its thing. Or it wouldn't make sense to write a program in our language that's one of those first 3 productions. The only way we can do something, make something execute, is through a call. That's why it's always hitting the else now, because that's what our code has to look like. Nothing keeps us from writing a program that's just an identifier. I mean, I can go in here and write a program that's just 7 once we're done doing this, and it will output a 7. So it won't go to the else in that case. It just doesn't, it's not functionally doing anything. All right, so that's what's in our parser. So now we have a new thing called a numlit expression in our parser. So we're going to go ahead and add that to our run. So if EQ of parse no code, the car parse no code, is equal to that dude, all right, then what am I going to do? Well, what do I do if I just see a lit expression? Return the value. Do I have to resolve it first? If I give you a 7 and I say, what's the value of 7? What's the answer? 7. It's itself. All right, so we will boil down to the catter of our parse no code. That is the car of the cooter. So the number that comes after numlet expression. So now that we've done that, I can pass in a 7 there, and we can still switch it back to our X. So I can pass in a literal here, an literal, instead of a variable, and this guy will ultimately get passed into X for the 7 and then boil down to a 7. So there's our 7 there. So we've expanded our language now to now support a literal type. Okay, pretty good, pretty handy. We've at least made it so that we don't have to hide things inside of variables whenever we need a number. Okay, well, what's next? Remember, we're inventing our language here, so we get to decide what features belong. Go ahead. Okay, how are you going to use string literals right now? Well, yeah, I mean, so we can have other kind of literal types, but are we going to actually use them yet? I guess we're working towards how do we make our language more functional than it is now in terms of being able to do stuff. Go ahead.
Ability to do simple operations.
Mathy stuff. All right, because now we have numbers. We have variables that resolve the numbers. So now it'd be nice to do mathy stuff with those numbers. Okay. And what do we want our, what do we want our mathy stuff to look like? So we want to create a syntax for our no language for doing some math. So do we say do math? Do math? No math? Who?
I'm doing everything else with that. Oh my gosh.
All right, so do we say do we want to call it do math? You want to say do mathy stuff? Okay. Yeah, that's a good question. We're about to run into that. So do mathy stuff. What's the rest of my syntax going to be? Well, hold on.
Well, number plus.
Mathy stuff involves more than just plus, right? We're going to apply a mathy operation to what? To two numbers.
Oh, yeah, math.
All right. So what are my two numbers? What's the format of my two numbers? Do they have to be a numlet expression?
It has to be at least a number. I'm guessing that would just fall under the line.
No lang expression. It has to ultimately boil down to a number. That's what our expectation is, just like down here. Our expectation is that this first guy is the function and the second guy is the parameter being passed into the function, right? But ultimately, we expect this to be anything that boils down to something that can be applied to whatever this boils down to. Just like up here for our mathy stuff, we expect to have two numbers. So no lang expression and a no lang expression. We expect those guys to boil down to a number somehow. That could be a variable that boils down to a number. That could be a literal that boils down to a number. That could be a call function that passes something into a function that ultimately boils down to a number. All right. Now, you said something about the mathy part of this. I have two numbers. I'm going to do something to those two numbers. What's the something I'm going to do? Some operation. Okay. And what operations do you want to support? Okay. So our normal mathy stuff, maybe addition, subtraction, multiplication, division, that stuff. Okay. So what's that operator? What's the format of that operator? Go ahead. All right, so we look at all of our operators. All those operators are what kinds of values? Symbol by our current state of things. We could make the argument that we actually can create another language, a language of math operations. Potentially we could. That way, whenever we added a new operation, we could. So, you know, these are the decisions as the language designer of when do we jump ship and say, I'm going to represent something in a more complex way to give me some future expandability. Or in this case, we might say, look, you know, my math stuff, my primitive math operations they're symbols. We're going to have a plus sign, a minus sign, divide, multiply. Maybe we'll do modulus, you know, but these are all symbols that we're going to be applying to ultimately numbers. Go ahead.
So theoretically, if you want to do stuff like this, derivatives and stuff like that, you would create another language.
Potentially. I mean, if you grew out of, I mean, because ultimately it kind of becomes spaghetti code. It's not that you couldn't accomplish it this way. And really, it actually comes down more to the documentation of it. Because here, we're just throwing this thing called symbol in here, where we're having to use our imagination on what that symbol might be. Where if we call this a no language mathy op reference, oh, ninja, super ninja. At that point, we might say, okay, well, our mathy op operations are going to be, we can have a plus sign, a minus sign, a divide, a multiply, those specific things, right? We can start with that. So then out here, we can specify that our do mathy stuff is a no language mathy op followed by two no language expressions. That then narrows us down and say, look, it can't just be any old symbol. It has to be one of these dudes, which then allows us, as you pointed out, to say, I'm adding more mathy stuff, but categorize it to make our language more formal, saying these are the only things allowed there. This is a subset of all symbols, right? And it also allows us to probably document our language a little bit better in terms of what our expectation is. Yeah. Well, no, for right now, I mean, this is effectively a synonym for the subset of symbols. So you have all the symbols, let's just call it the Unicode character set. Okay, that's 65,536 unique symbols. But now we're going to say, you know what? I got these mathy ops that they're all symbols, but only some of those actually belong to that category, right? So these are still reserved words in your language. You don't have to go and store them somewhere. You're just pigeonholing yourself and saying, look, if you're going to build a mathy, do mathy stuff expression, you can't just give me any old symbol. You got to give me one of these dudes. So then as the programmer, we say, okay, I'm looking at the documentation. I say, okay, well, I have to give it one of those dudes. What are those dudes? Turn the page in your documentation, boom. Those are what those dudes are. That's what's allowed. So do you see how being a little bit more formal and being a little bit more explicit actually gives us a better documented language? Otherwise, we're going to hit the else all the time, potentially, right? If somebody's either writing bad code or just being, a wise guy saying, look, I'm going to perform, the math operation X or P, or Q to these numbers, just cause, when it really has no actual meaning. All right, so we'll call it a no language mathy op. So here's our do mathy stuff. That's going to be a no language expression. And he's going to take in 3 parameters: the no language mathy op, the no language expression, and another no language expression. All right, so we're adding the feature to our language to do mathy stuff. And I'll put a closing parenthesis there in the end. All right, so we now have a mathy op language, right? We have a programming language. Well, programming language is the wrong term, because I've met, way back in 200, I said that a programming language has to have the ability to remember stuff, ask questions, and repetition. But we can have a language here. We do have a language of no language mathy ops. And that language contains exactly 4 symbols right now. These 4 symbols. Okay. Now we can decide how we want to handle this. We can write a whole parser for this dude if we imagine this is going to get very, very complex, and we're going to have integration, derivatives, things like that, and maybe supporting matrix operations, whatever it is. But right now we're thinking it's pretty simple. Let's not overkill this with abstraction, because then we're going to get lost in that. So really, we don't need to do something special when it comes to parsing and ultimately running our code here. So we know that this dude ultimately is just going to be a symbol. All we're saying is we expect it to be one of this very small subset of 4 symbols. All right, so we don't need to throw it off to some other machinery and let it go ahead and do some magic to the plus sign to give us the plus sign. I think we can work with a plus sign and say, guys, what you want me to do? Add stuff. Yeah.
So in C, we wrote the thing earlier that I took in a function like symbol or number, and if there was one number or something along those lines. Are we going to be doing this in you don't write different functions for add and subtract and multiply around to the language expression and to whatever the you have to do?
I'm not sure how those are related.
So like instead of having like in the number you have like if it's a plus, if it's a subtract, you have.
Oh, I see what you're saying. We'll actually need to have a secondary piece of machinery, a function that will pass a math operation to, as well as 2 numbers, and have it perform that job. So we can think of it like a toaster. We toss it the what do we call it? No language mathy op and 2 numbers, and it pops out an answer that ultimately performed that mathy stuff on those parameters. You wouldn't have it probably built into your run, our apply expression thing right now.
So you wouldn't have one add addition poster, one subtract poster.
Probably not. Internally, they might have, those would probably be productions in the cont. If it's a plus sign, do addition. If it's a minus sign, do this. If it's a, and we'll see that here in a minute. We'll write this guy. All right, so we're creating this do mathy stuff. So this is going to be our language syntax. This do mathy stuff. So we need, our go-to move is update the parser, then update the executioner, the thing that runs it. So we'll go up to our parser. Now, ultimately, what we're trying to accomplish is maybe something called do mathy stuff plus A, B. So now we're going to pass in as a parameter to this function, the do mathy stuff of applying this math operator to A and B, which boil down to 7 and 5. So you should get a 12 out of this. So this whole thing should boil down to a 12, which then gets passed in for X. And this guy just boils down to that X, which is 12. Make sense? That's what we ultimately want to be able to accomplish. So we got to go up to our parser here. All right. So we're not looking at a number. We're not looking at a symbol. So now we're interested in what the car, we know we have a list, right? And we're interested in what the car of that list is. And we want to know, is the car of this list, and actually I don't need to have, I wouldn't write it like this. I would write it like that. I don't need to have the whole thing is quoted here. So I'm going to ask if equals the car of our no code, if that guy is a do mathy stuff, if that's what I'm looking at, I want to do some mathy stuff. All right. So I'm going to put a couple of dots here just to remind us where we are in the world, because we need to go build our toaster, right? The guy who we can toss a math operation to, pass him 2 numbers, and then say, okay, give me the answer. That's what he does. That's his whole job in the world. Rather than embed it in here, let's just go out and buy an appliance. All right, so we'll create another function here. Define do mathy stuff, toaster, to be a lambda. And this guy's going to take in a op, a num1, and a num2. That's what we expect him to give us. All right, and we'll do a cond. Equal op plus sign, then return plus num1, num2, equal op minus sign, return minus num1, num2, equal op divide. And if we wanted to use a different symbol, we can say div or something like that, but we'll stick with what we are used to. Then we'll divide num1, num2, and this will do floating point division. If you want integer division in scheme, I think the function is quotient, but we can deal with that later. We want to add that ability. So EQ op multiply. Actually, I'm going to add it here in a second because I think that will give us a little insight into why Python works the way it works. What's the integer division operator in Python? Double slash. EQ op that guy. So if we pretend for a second here that we are inventing Python, we needed to come up with some sort of differentiating operator to say, do I want to do floating point math, which is the default division, versus do I want to do integer math, which is the, 5 divided by 3 is 1, not 1 point something. So if we're going to have that, it might make sense for us also then to have, here, I'm just going to throw an else in here. We'll just have it return false just as a catch-all. Like, look, you asked me to do something that doesn't exist. Might it also then make sense to have a mod? And if we want to stick with kind of a C style, you have the % symbol. And I think it is modulo. Num1, num2. Test that real quick. Yeah. 3 goes into 5 one time with a remainder of 2. So modulo is the scheme function for getting the remainder of integer division. While I'm in here, let's just test to make sure I have it right for the quotient thing. Quotient. Yeah, so there's the integer division of those guys, because if I do 5, 3, I get floating point math. So what we're looking at right here is the rationale. Why did these 3 different things? This dude will do floating point math. Division, the way division was born to be. This guy, these 2 allow me to accomplish integer division in my language, getting both the whole number portion and the remainder, if I want to use them. It's just, we got the super version of our toaster was on sale on Amazon. Prime Day sale. Just what also does Baby Yoda on the toast, but it's what? Oh, right. We can't call him Baby Yoda anymore because he has a name.
No.
Oh, from the backstory of it. It's like, no, it's canon.
Okay, no, but like the actual correct.
No, how that just defends what you said earlier about, that, okay, this group might be into tabletop D&D. I feel like this even narrows it down even more. Anybody who uses the frame, it's canon, probably is into tabletop D&D. Then you get into these arguments over, 1st, 2nd, 3rd, 4th edition. Yeah, it's like, yeah, 5th edition just ruined everything,
Okay, I've got that.
What was the 3rd edition that introduced the idea of feats? Come on. I mean, back in the day, we used to mix with other role-playing books. There was a book that I used to use in my D&D campaigns called Roll Master, a really old thing, and they had this these crit tables. You'd have entire volumes of crit tables with different weapons. I mean, this thing got granular, because there was this one campaign where I was a wizard and I refused to use magic because I get into character and I stay with character. So I was a wizard who didn't use magic. So a very weak type person who I would just pick up sticks and stuff. So I was rolling all my attacks on this from Roll Master, this table called the Horned Tusk table. So if you were attacking with a horned tusk, this is what you, this one time I was like not contributing at all, basically, because I was a wizard trying to do melee. And I rolled a natural 20 on the horned tusk table. And I just decimated this dude with that stick. And I was that week's MVP. Yeah. Yeah, except an archer in melee range, because they identify as an archer, doesn't make sense. A wizard in melee range who identifies as a non-magic user makes a lot of sense. that person's crazy. You want to steer clear because you don't know what he's carrying. Might have some sort of poison bomb or something like that. It could be gnomish made. Have you even thought this through? Is what I'm saying.
Or he could just.
She's like, yeah, have you even thought this through?
Oh, we have 5 seconds, man.
Ay, ay, ay. Oh, what got us there? Oh, Baby Yoda. Cannon, Baby Yoda, horned tusk crit table. All right. So these 3 dudes right here just enhance our language to allow us to do division-y things both on the floating point and the integer side. And we just needed to make sure that we're calling under the hood the correct scheme functions to accomplish what we want to accomplish. We've noticed that scheme's division symbol does floating point math, which means that we had to identify the other 2 functions that allow us to get the whole number integer division and the whole number remainder of integer division. All right, so this is our do mathy stuff toaster. So this is the guy who executes mathy stuff. All right, so if I am currently looking at a do mathy stuff, which looks like this, where I have a do mathy stuff is the car. The catter is my operator. And the CADDR is my first value. And the CADDDR, but you say we can't do that deep into it? Are you sure?
I guarantee it.
You lying? By not having the apostrophe before, what's it trying to do?
It's putting 1 as column.
Yeah, it's trying to treat this as a function called 1. So by quoting it, I'm saying, don't try to do Matthews. Ha. Ha.
I think you can go past 30. I think it's the 4th, isn't it?
Well, I'm on the 4th.
Is that 4? No, we have 4. Yes.
So we can accomplish what we're trying to accomplish then, right?
Yes.
Well, you seem so sure of yourself too.
It didn't work yesterday.
Oh, I'm sure that's a lie. This is the guy who accidentally rolls a D12 instead of a D20 for his attack roll.
I think that was D1. You just ethically failed that.
A D1 would be a same-sided coin.
Yeah.
Was it? That's what it's got to be.
Yeah.
Because you're always going to get, you only have one choice. So it's got to be a penny with the heads on both sides. You don't have to roll it, actually. You just say, this is, it's a ticket, really. What's up?
I do have a legitimate question.
If it doesn't involve D&D, it's not legitimate.
But
Right?
it's not-
Go ahead.
The, how do I pronounce that? The cat did their, is that actually a function or is it just thinking it's a function?
Which one? This right here?
No, the one below it.
Well, no, it's not a function. See, we got the error.
Yeah.
It's saying we can't stream this many of these together.
Oh.
But I mean, what we're trying to do here, this is just syntactic sugar. This is the car of the cutter of the cutter of the cutter of the cutter. You can always write it out. This just is a little bit shorthand to save you some parentheses. All right, so if where's my mathy? I'm lost. Where's my mathy expression?
You didn't put it in wrong.
Are you lying?
Oh, it's in the parser.
Oh, there we go. So I need to create, if I'm looking at do mathy stuff, I need to create my parsed version of this, right? So maybe we say we're going to create a list. That's a math expression followed by a our operator, which is the catter of no code, followed by our what do I put next? Go ahead. Say that one more time. How do we do that? No parser. So we can't just use the CADDR. On its own, we don't know enough. We have to call no parser on that guy. Our math op is good as is, right? We know, since we wrote this, that our math op is just a symbol. It doesn't need any other processing, just our documentation says, here's the subset of symbols that it must be, okay? But for those other pieces, and here, I'm gonna kick this down a line. We're gonna call our no parser on the CADDR of no code, and then no parser on the CADDR of no code, which we've been told doesn't work, but we're going to write it anyways, and then we're going to be surprised when it works. But it didn't work yesterday. It's a software update that I didn't run.
Would you want, math expression to be outside the list of the symbol and numbers?
Who?
So you want like a list that contains math expression and then inside that a list that contains the symbol and the numbers?
I mean, if you want your parsed version to look like that, you could.
Because when we do home expression, we get a home expression and then another list of them.
With this guy? If I'm looking at a function, I'm creating a list that has func expression, and then I'm appending onto that. Well, no, the only reason there was a list is because a func expression has a parameter list. You have your params. And this guy boils down to a list. So we just made it look like here, this is your parameters for your function. Yeah, so we labeled the parameters. So I don't think they're related, those two. I mean, I think a function, we kind of expect that second thing to be a little bit more robust and say, these dudes are your parameter, because that's certainly setting us up for having 0 or more parameters. You know, with our current knowledge, I think you're right, where we can say, look, if you're only ever going to have exactly one parameter, do we really need to wrap it in something, or can we just make the second element that parameter? But we can foreshadow a little bit and realize that we probably want to have more flexibility with our functions. So in this case, I don't think we need more flexibility than to have a single math operator when we're doing it on two numbers. All right, so we're going to create a list, math expression with, here's our operator. This is going to boil down to the parsed version of our first presumably number. And this will boil down to the parsed version of presumably our second number. Make sense? All right, so that's in our parser. So now we'll go ahead and put this right before our func expression in here. What am I doing? I'm lost. It's equal to that guy. If I'm equal to a math expression, what do? Who runs math expressions? The toaster. Do mathy stuff toaster. That's the dude who runs math expressions. So I'm going to call upon my toaster. My toaster requires an operator for me. And that operator is going to be the catter of my parse no code. And then he needs me to pass him 2 numbers. Where do I get those numbers from? Somebody else. We have a very core group of people who's answering everything. So I currently, here I'll draw what we have in our, this guy right here will turn into math expression plus sign var exp a var exp b. That's what I'm looking at. The thing whose car is a math expression. That's what we've written right here. We're going to call do mathy stuff toaster on the car of the cooter of this dude, which is the mathy thing we're going to do. But now I need to give him the 2 numbers. How do I get the number out of this guy? Go ahead. Okay, well, that'll give me an A. I want the number. How do we get the number of that no expression? Who knows how to turn that guy into a number? Ultimately, resolve will do it, but do you want to make these special cases? Do I already have a special toaster that I could pass that dude to that will convert that into the resolved version of A? Yeah, this dude. I already got a toaster. If I toss this dude, this guy, and the current environment, he'll do the job, right? Ultimately, you're right. He will come in here and he'll call resolve on it. But we don't want to just haphazardly have resolve like, okay, well, I can do var expressions up here, or I could just, I'll just inline it right here and just do it again. We already have a tool that does this. So we're going to call run parsed code on the CA DDR of parsed no code. Similarly, I'll call run parsed code on the CA DDR of parsed no code. Oh, thank you. And whenever you call run parse code, you always have to pass it the environment in which it's executing that code. And we look up at our toaster, make sure that that guy takes 3 things, an op, a number, and a number. Here I'm calling that toaster, do mathy stuff toaster, I'm passing it an op. What I hope ends up being a number that comes out of executing that expression, and what I hope turns out to be a number from executing that expression. So that should be it for a math expression. So looking at my program here, get rid of this piece. We hope the output of this to be A plus B. A is 7, B is 5, so that's 12. So this is going to boil down to 12 being passed in for X, and then this guy just boils down to whatever the value of X is, which is 12. So the output of this should be 12. And there's our 12. So now we can do math stuff. And if you want to do mod 7 mod 5, 5 goes into 7 one time with a remainder of 2. So this should give us a 2. There's our 2. So now our language is starting to do some stuff, right? All right. So what's next? What's the next thing we want our language to be able to do? Maybe. Make it ask questions. What about more parameters? Yeah, you don't want it to do more parameters yet for our functions? How about 0 or more parameters? This is our language. Well, actually, it's no language. Just let me get it right. There is a Rollmaster has a crit table for natural ones when you horribly mess up. It's pretty bad, actually. Go ahead. You have your language calculate pi. We can make that the assignment.
You've got to look at the time.
Yeah.
Just letting you know.
Homework. Modify our no language to support functions that take 0 or more parameters. Submit the code. Actually, we're probably getting to the point where I want to link to a code. Submit a link to the code. GitHub, desktop, maybe something like that. Whatever tool you want to use, give me a link I can click on and view your code. Submit the self. And you probably want the current state of the code. All right, questions, comments, concerns, bribes. See how much better our language is now? It's gonna be so good. All right, I'll see everybody on, what's today, Thursday? See everybody on Tuesday.